All right, this is lesson 84. Ellipses is the next shape we're going to be looking at. Ellipses and circles are very similar. Talked about circles. Ellipses are just circles that are like, they look like ovals. They're kind of squished in one direction or spread in one direction, either up and down or left and right. We have an equation for them, and they're one of the four that we're looking at. So, here are the steps for today. This is our new equation. I want you to look at it right now. Look up here, please, and tell me, or not tell me, but just think about what are the similarities of this equation and the one for the circle. What are the differences that you notice? And then a couple things you have to see is the center is h and k, so that's a really important pair of numbers, h and k. The width of the ellipse from the center is a. The height of the ellipse from the center is b. Okay, and I'm going to show you how to graph. That's the goal for today. How do we graph ellipses? Okay? Here we go. I'll show you how to do a couple of them, and then you will do a few together, and then by the end you'll get it. It's pretty easy. So, okay. So number one, we have x squared over 4 plus y squared over 16 is equal to 1. All of the examples today we could assume are ellipses. At one point though, I'll say graph, and you'll have to know that this is an ellipse just by the way it looks. Okay, so on number one, we have x squared plus 4 is equal to y squared over 16, which is equal to 1. The first thing I want to do is make sure it's in standard form, which has to look like this equation up here. It's not, so of course we could assume h and k are 0, but just to make sure you guys see it, x minus 0 squared is in the first numerator, and the second one we could replace with y minus 0 squared, okay? So our center is at 0, 0. So the first thing you want to do is plot the point as 0, 0 on your graph at the origin. Okay. Then our a squared is the number under the x term. Okay, so a squared is the number under the x term. The number here that's here already is 4, so a squared will be equal to 4. Oh, went too fast here. So if I wanted to take the square root of both sides, I get a is equal to 2. A represents how far to the left and to the right you are from the center of your ellipse. So I would count a couple spaces to the right and a couple spaces to the left and put points there. So I'm going to put a couple points there. Okay. Then I'm going to look at what b squared is. B squared is the number that's under the y term always, okay? B squared is equal to 16. So I'm going to do a side equation. If b squared is equal to 16, b would be equal to 4 because I take a square root of both sides. So b represents how far up and down from the center point your ellipse will go. So from the center point, we're going to go up 1, 2, 3, 4, and down 1, 2, 3, 4 in each direction. So we're going to plot some points. Okay, now that we have all the points around, we're going to connect it with a nice curve around the whole graph, okay? And that's how you do number one, okay? Does that make sense? I'm going to explain it one more time because it's the first time we saw it, okay? Just so you got the picture, okay? So, again, from the beginning, first thing you want to do is figure out what the center is. We have h and k. We know that are going to both be 0 because it's not represented. So your center is 0, 0. Plot the point. Then we figure out what a squared is. A squared is the number underneath the x term. So a is equal to 2. It's how far to the left or right the points are. B squared is how far up and down the points are. So b squared is equal to 16. So b is equal to 4. So we go up and down 4. Connect all 4 points with a nice curve. Does that make sense? Okay, number 2. We have y or x plus 2 squared all over 25 plus y minus 3 squared over 9 is equal to 1. So the first thing you want to do is figure out what your center is. Our center in this case is negative 2, positive 3. So we're going to plot a point there at negative 2, positive 3. Then we want to figure out what's a squared. A squared is always under the x term. So a squared is equal to 25 here, right? So the square root of both sides, a is equal to 5. So we know that we're going to go left and right from the center 5 points. Now look, I'm going from the center of the graph, not the center over here, but the center of the graph. So I went over 5 to the right and over 5 to the left. Okay? Then we're going to look at b squared. B squared is the number underneath the y term, so square root of both sides, b is equal to 3. We're going to go up 3 and down 3 from the center. And then we have all 4 points there, so now we're going to draw a nice curve around the whole thing. And we're done. That's how you do number 2, okay? Ellipses look just like circles, right? Except that they're squished or they're elongated in a certain direction, okay? So, and notice that they could either be stretched up and down or left and right, okay? That's the only way we could graph them right now. When you go to advanced math or when you go to calculus, you'll know how to spin or turn these around. But for now, you just need to know the basic forms. Okay? Questions? Okay, so today's Thursday. Let's have twos talk first. Twos will talk about number 1 first. Twos are talking first about number 1. And then once they're done ones, we'll tell the twos about number 2. Ready, set, go. Please, number 3, y squared, x squared over 49 plus y squared over 9 is equal to 1. Please write that down. Oop. What would our h and k here be on number 3? 0 what? What? 0, 0, right? 0, 0 is our center, so we're going to write, you could rewrite it if you want, like what I'm doing right now, x minus 0 squared plus y minus 0 squared. You don't have to, you could assume it's 0, 0. Okay, just like circles. So center is 0, 0. So let's go to, let's write that down and also plot our point in the center as 0, 0. Okay. Next thing. A squared. A squared is always under the x term. Okay, always under the x term. What's the number under the x term?
49.
49. So a squared is equal to 49. How do I get a by itself? Square root both sides. You're working along with us, right, Ely? A is equal to what? 7. Okay, so again, A represents from the center how far to the left and right from the center you're going to plot points. So count 7 to the left, plot a point. Plot 7 to the right, plot a point, please. Okay. Next, we want to look at b squared. B squared's under the y term. What's b squared equal to, everyone? 9, good. So if b squared's 9, what is b equal to? 3. Okay, b represents how far up and down from the center you're going to go plot a point. So let's count 3 from the center, plot a point, 3 from the center, plot a point, up and down. Okay? That makes sense? So we're going to graph now. We got 4 points, so I'll graph mine, and then I want you to do the same thing on your iPads. I'm going to come around and check your work right now. Okay, I'll give you about 30 seconds to catch up. All right, it is taller, okay? By the way, couldn't you predict if it's taller or wider by the denominator without graphing?
Yeah.
Yeah, so that might be a question I might do. I might say, is this one going to be taller or wider? Okay? So, and there, we're going to talk about these extra terms. I'm not going to talk about them today, but there's some extra terms that we're going to develop. But for now, this is the goal, is just to graph this. Okay, next one, number 5. Okay, number 5. Let's do this one together. I'll start us off, and then I'll have you finish it off. So this one is a little different. Our center, is it 0, 0 still?
No.
No, what's our center on this one?
1, 1.
1, 1. Good. So our center is 1, 1. So since it's 1, 1, we're going to go to 1, 1. Now, I want you to be very careful when you're plotting your A and B. You're always counting from what the center point is, not the origin, but the center point. Okay. So, what's A equal to in this example, everyone?
4.
Well, A squared's 4. A is 2, right? So let me just start us off here. If A is 2, we're going to go from the center point and count 2 to the right and 2 to the left. Okay, so we're going from that center point. We're going to go 2 to the right and 2 to the left. We have B is equal to 3. Okay, so yours should look like that. I'll let you finish this example off. You should have counted up and down 3, and of course you're having your graph look like that. Okay. Last one, number 6. I'll start us off here, but there's number 6. There's one more concept. So look at our center. Center is what, everyone? 2, 2, right? Like a ballerina. All right. 2, 2, so we're going to plot 2, 2. And then a, what's a squared equal to?
15.
15. So what is a equal to? What? No.
15 squared.
Square root of 15, right? That's what a is equal to. We have to estimate, right? Because actually the square root of 15 is irrational, meaning like if I put it in a calculator, it's this long decimal, right? Does that make sense? It'd be, so we have to estimate it, right? Square root of 16 is?
3.8.
Square root of 16 is? Square root of 9 is? Good, so without using a calculator, okay, well let's estimate. Is it going to be close to 4 or close to 3? Good, it's going to be about 3.8, right? So we use rad 15 because it represents the actual number. This is irrational, so we need to think, oh, it's about 3.8. So when I graph, I'm not going to count all the way to 4. I'm going to only count to about 3.8, okay? Same thing with B. What's B equal to here, everyone?
2.2.
No, it's not equal to 2.2. What is it? B is equal to what? Rad 5, which is about 2.2. Is it equal to 2.2? No. Okay. I want you to know that concept. Okay. So center points here. Please take that in consideration as you graph this last example. Go. When you're counting your A and B, you're not counting exactly on a point or on the like a lattice point on the graph, but you're counting it a little bit past a certain number, right? So we're estimating. Okay. There you go. That's how you do the last one. Now I know you can use the ellipse tool on your iPads, but on your homework tonight you'll have to like actually draw it out. Okay. Make sure you have a curvy line all the way around. It's kind of like your ellipse tool. You should be good. All right. That concludes the lesson. I'll post that right now.